There is no edge of the universe, but there is a wall of time. You are standing on a planet. Right now, that feels like the whole story. But what you're about to see is that your planet, your solar system, your galaxy, everything you have ever known, is a single pixel in a frame so vast it breaks the meaning of the word vast. So let's pull back. Earth has a radius of 6,371 kilometers. It took humanity roughly 300,000 years to circle it. But the first time we left it entirely, in 1968, the Apollo 8 astronauts looked back and saw something that made them rewrite their captions. Earth was not a world. It was a marble. Now pull back further. Earth orbits the Sun at 150 million kilometers. That distance is called 1 astronomical unit. Light crosses it in 8 minutes and 20 seconds. If the Sun vanished right now, you would not know for 8 minutes. You would keep eating your breakfast under a ghost star. The solar system, if you include the Oort cloud, is about 2 light-years across. That means it takes light itself, the fastest thing in existence, 2 full years to travel from one edge of our solar neighborhood to the other. And we have sent exactly one object, Voyager 1, past the heliosphere. It took 35 years. Now zoom out to the next scale. The nearest star system, Alpha Centauri, is 4.24 light-years away. With our fastest current spacecraft, that trip would take about 70,000 years. Let that sit for a moment. 70,000 years to reach the nearest star. That is longer than all of recorded human history, and there are at least 100 billion stars in our galaxy alone. The Milky Way is about 100,000 light-years across. It is a barred spiral galaxy with a supermassive black hole at its center, Sagittarius A, weighing in at roughly 4.1 million solar masses. When you look at the band of the Milky Way at night, you are looking sideways through that disk. You are inside the galaxy looking at its body from within. Here is where the first strange thing happens. When you look at a star 10,000 light-years away, you are not seeing that star as it is. You are seeing it as it was 10,000 years ago. You are looking through time. Every telescope is a time machine. And the further out you look, the further back you see. So let's keep pulling back. The Milky Way is not alone. It is part of a cluster of galaxies called the Local Group, which spans about 10 million light-years. It includes the Milky Way, Andromeda, the Triangulum Galaxy, and about 80 smaller galaxies, many of them dwarf galaxies orbiting the larger ones like moons around planets. The Local Group sits inside the Virgo supercluster, which is roughly 110 million light-years across and contains at least 100 galaxy groups and clusters. But even that is not the top of the ladder. In 2014, a team led by astronomer Brent Tully mapped the positions of galaxies and found that the Virgo supercluster is itself just a lobe of something much bigger. They called it Laniakea. It means immense heaven in Hawaiian. Laniakea is a supercluster complex spanning 520 million light-years and containing roughly 100,000 galaxies. Its gravity defines what we call our great attractor, a gravitational anomaly pulling everything in our region of space toward a point we still do not fully understand. But here's the twist. Laniakea is not the end. It is one filament in a vast cosmic web. If you zoom out far enough, galaxies stop looking like individual objects and start looking like threads. They form a network. Strings of light-connecting nodes, with vast dark voids between them, like bubbles in a foam. This is the large-scale structure of the universe, and it is the largest thing we can observe. Now, how far can we actually see? The answer is the observable universe. It is a sphere centered on you, and it has a radius of about 46.5 billion light-years. Not 13.8 billion, which is the age of the universe. 46.5 billion. That number should confuse you. It confused physicists for decades. Here is why. The universe is 13.8 billion years old, so light from the earliest galaxies has been traveling for about 13.8 billion years. You would think that means we can see 13.8 billion light-years in any direction. But space itself has been expanding this entire time. The points that emitted that ancient light have been carried away from us by the stretching of space. They are now 46.5 billion light-years away. This is the key idea. The universe is not expanding into anything. There is no outside. Space is getting bigger. The distance between any 2 points that are not gravitationally bound is increasing. Not because the galaxies are moving through space, but because the space between them is being created. Imagine dots on the surface of a balloon being inflated. The dots are not crawling, the balloon is growing. So the observable universe is a sphere with a radius of 46.5 billion light-years, centered on you. And it has a diameter of about 93 billion light-years. Inside that sphere is everything you can ever see, know, or interact with. Outside that sphere is everything else, and we will get to what that means. The boundary of that sphere is called the cosmic horizon or the particle horizon. It is not a physical wall. You will not crash into it if you fly far enough. It is a limit of information. It is the maximum distance from which light has had enough time to reach you since the universe began. Think of it this way. If someone is standing beyond the horizon and shines a flashlight at you, that light has not had enough time to arrive. It is still traveling. You cannot see them. They cannot see you. You are both real. You are both in the same universe. But you are invisible to each other because the universe is not old enough for your light to have crossed the gap. And here is something that makes it stranger. The horizon is personal. If you are on Earth and I am on a planet 10 billion light-years away, our observable universes overlap, but they are not identical. We have different horizons. We can see regions the other cannot. Every observer in the universe sits at the center of their own observable sphere. So when we say the edge of the observable universe, we do not mean the edge of the universe. We mean the edge of what light has had time to show us. It is a visibility limit. It is the boundary of a sphere of information, and that boundary is defined by the age of the universe and the speed of light. Now let's go to the very edge. The most distant light we can detect is not from a star. It is from the Big Bang itself, or more precisely, from about 380,000 years after the Big Bang. Before that time, the universe was so dense and hot that photons could not travel freely. Space was opaque. Light was trapped in a fog of scattering particles. Then the universe cooled enough for electrons to combine with atomic nuclei, and space became transparent. Light was finally free. That first light has been traveling for 13.8 billion years, and it fills the entire sky. We call it the cosmic microwave background, and it is the oldest thing we can ever see. It is a baby picture of the universe, taken when it was a fraction of its current size. That cosmic microwave background is the horizon, visually. It is the wall of fire we see in every direction, not because the universe ends there, but because before that moment, light could not travel. We cannot see beyond it. Not because nothing exists there, but because the information is locked behind a wall of opacity. We are seeing the moment the universe became transparent. So the edge of the observable universe is really the edge of time. It is the earliest moment from which information can reach us. It is not a place. It is a moment. You are not looking outward when you stare into the deep cosmos. You are looking backward through layers of time toward the beginning. Now, the harder question, how big is the actual universe? The one beyond the horizon? The honest answer is we do not know, but we can estimate. Based on measurements of the curvature of space, the universe appears to be flat to a precision of about 0.4%. If it is truly flat and infinite, then the universe extends forever, and the observable part is an infinitesimal fraction of the whole. If the universe is finite but unbounded, like the surface of a sphere, then it curves back on itself. You could fly in a straight line and eventually return to your starting point, the way you could walk around the Earth and come back home. In that case, the total universe is at least 250 times the volume of the observable universe, and possibly much more. Some inflationary models suggest the universe is so large that the observable portion is like a single grain of sand in the Sahara. In this picture, there are regions of space so far away that their light will never reach us, no matter how long we wait. They are not beyond a wall. They are beyond time. The expansion of space is carrying them away faster than light can catch up. This is because of dark energy. Discovered in 1998 through observations of distant supernovae, dark energy is accelerating the expansion of the universe. The further away something is, the faster it recedes. Beyond a certain distance, about 16 billion light-years, objects are receding faster than light. Their light will never reach us. They are disappearing, one by one, from our observable sphere. This means the observable universe is shrinking. not in physical size, but in the number of galaxies whose light can still reach us. Billions of years from now, observers in the same location will see fewer galaxies. Eventually, they will see only their local group. The rest will have crossed beyond the horizon into permanent invisibility. They will think the universe is mostly empty. They will be wrong. So the edge of the observable universe is not a place. It is a horizon of time, light, and expansion. It is the limit of what the universe has had time to tell you. Beyond it, the universe continues, vast and possibly infinite, full of galaxies and stars and worlds and maybe observers of their own, staring at their own horizons, wondering the same thing you are wondering now. The universe is not showing you everything. It is showing you what light had time to deliver. The edge is not out there. It is in the age of the cosmos, in the speed of light, and in the stretching of space. You are not small because the universe is large. You are small because you can see how large it is, and you can understand that what you see is only the beginning of what exists. Subscribe to keep exploring the edge of everything we can know.